Okay, so you have on 23 1 minus 1 over 2x plus 1 minus 1 over 2x plus 1 squared equals 0. That one? What's a great thing to do first? What's a great thing to do first? You could find a common denominator. What's the least common denominator going to be?
2x plus 1 squared.
So you could just start by multiplying everything by 2x plus 1 squared. You can multiply everything by that. We've done that before. So what's 1 times 2x plus 1 squared?
2x plus 1 squared.
Thank you. It's just 2x plus 1 squared, right there, minus, what happens when you multiply this by this one right here? What happens? One of them cancels, so it's just 2x plus 1, and then minus, what happens when you multiply this one right here?
Stays.
What cancels?
The 2x plus 1 squared.
Yeah, so you're just left with minus 1. And what's 0 times 2x plus 1 squared? 0. So a great thing to do is to multiply by that least common denominator when you can. And now at this point, is that in standard form? No, it's not. It's not in standard form. So what could you do at this point? One word. What could you do? So you're going to simplify, so distribute. Yeah, exactly. So you could do that right now, absolutely. So what would it be? It'd be 4x squared plus 2x plus 2x plus 1 minus 2x minus 1, because negative times 1 is negative 1 right there. You just have to be careful. So now we have to clean this up. So if we're going to clean this up, what cancels here? Does anything cancel nicely? That's gone with that, right? And maybe that 1 is gone with that one. So what are you left with? 4x squared plus 2x minus 1 is equal to? And at this point, what should you try to do? If you can, what should you try to do? You should try to factor. Is this one nicely factorable? Does it look like it's nicely factorable? What do you think?
Sort of, yeah.
Kinda. I mean, you want to test it at least. So maybe like 2x and what? Maybe this? Maybe. But then the other two numbers, what do the other two numbers have to multiply together to get? Negative 1. So you only have 1 and negative 1 or negative 1 and 1. Doesn't look like it's going to work on this one. So what could we change? Not have a 2x and 2x. What could we have?
4x.
Yeah, the only other way to get a 4 is to have 4 and 1. So what do we have? We have, Aubrey, can you shut the door, please? Like this. So maybe, what do you want to try? What two numbers multiply together to get negative 1? So we could do negative 1 and 1, right? Is that going to work? You're going to get 4x. You're going to get 3x instead of 2x. So at this point, what should you do?
Quadratic.
Yeah. So A is what?
4.
B is? C is? Yeah. And what do you find first? Yeah, b squared minus 4ac. So that's going to be 2 squared minus 4 times negative 1. What's 2 squared? 4. And then you have a negative and a negative. So what's that going to be? Plus what? 16. So you get 20. Nice. So therefore the answer is going to be x equals negative b, so negative 2, plus or minus the square root of 20 all over what? 2 times a? What? So 8. Yeah, so that right there is negative 2 plus or minus 2 root 5 all over 8. Negative 1 plus or minus. Yeah, and when you get an answer like that, what does that mean about the factored form? It wasn't nicely factorable. It wasn't nicely factorable. We ended up with something with a radical in it, and that definitively means not nicely factorable. Nice. Okay, make a chart. So we have trip A, and we have trip B, and we have distance, rate, and time. What's the distance for both trips?
40 miles.
40 miles? Exactly. What's the rate for the first trip? At the moment, do we know what the rate is for the first trip A? No, let's say it's R, right? But what's the rate for the second leg? R plus 10. Exactly. And what do we know the relationship is between distance, rate, and time? What do we know the relationship is between distance, rate, and time? Well, distance equals rate times time. So what does that mean time is equal to? What does time equal? What? D over R, right? Time is equal to D over R. Is that correct?
Yeah.
So in this case, what's the time going to be right here? 40 over R. Very good. And what's the next one going to be? r plus 10. Okay, so we filled in the chart with only one variable. That's great. You want to avoid adding variables if you can. The question then says, driving time for the entire trip was 88 minutes. For the entire trip was 88 minutes.
So all that equals 88.
So all, what do you mean? Can you be more specific than all that? 40 over r plus what?
40 over r
Plus 10 is equal to what? 88. You have to be very, very careful at this point. You have to be very, very careful at this point because, can someone tell me what I'm insinuating you have to be very careful of at this point, Alex? Yeah.
So since we're using like miles per hour.
Units. Yeah. Yep. Hours. So here's the thing. Our rate, what units are our rate in right here? This is miles per hour, right? But this right here, what is this? Right there.
Minutes.
That's minutes. So if you did this, it's not going to come out correct because you have minutes in miles per hour. Does that make sense, everybody? So what do you need to convert 88 into? You need to convert it into what unit? Into hours, right? Or you need to work on your rate. It's easier just to do the 88 minutes. So that's 1 hour. So you can do this a few ways. So you know it's 88 over 60 hours, right? So literally, instead, just write it like that. So instead, write it as 88 over 60. Now, can a lot of these things be simplified? Sure, that's the whole point of this operation. We're trying to solve for r. Because that's how many minutes are in 1 hour. 88 minutes. If this is 88 minutes, 88 minutes over 60 is equal to hours. That's how many hours it is. So if you have 90 minutes, how do you convert 90 minutes to hours? You divide it by 60, and you get 1.5, right? So on this one right here, now we just need to simplify this thing right here. How do you want to go about simplifying this one? What do you want to do first?
You can multiply the first one. Well,
You could do a lot of multiplication, but there's something you could simplify first. Take the easy things first. What could you simplify first, Alex?
You can convert 88 over 60 to
Like 44 over 30, right? Which is what?
22 over 15.
Now, it might not seem like it's doing much, but is it kind of nice not to have to deal with larger numbers? Yes, it's nice. So all we did right there is do the easy, 22 over 15. So at this point, what do you want to do? Someone tell me what I should do next.
multiply by the LCD.
You could multiply by the LCD. In this case, what's the LCD going to be, Mar? Give you a hint. It's r times r plus 10 times what?
Oh,
15. Okay, so when you multiply that by 40 over r, just the r cancels, leaving you with what? 40 times r plus 10 times 15. And the next one, the r plus 10 cancels, leaving you with what? 40 times r times 15. And only the 15 cancels here, so it's 22 times what? R times r plus what? 10. So at this point, you have a quadratic. Is it written in standard form?
Yeah.
Wait, that's standard form?
No, I said not.
Oh, not yet. I thought I said yeah. I don't know why I heard that. It's not yet. So do this for me right now. Write that down and then go to standard form and then stop. I'm interested in what A, B, and C are. Go to standard form. Take this right here and write it in standard. Is that in standard form yet? No, not quite. So you end up with 1200R on this side plus 6000 equals 22R squared plus what? 220R. So we got 0 equals 22R squared. And you have this and this, right? So how many R's are we going to have left here? Negative 980. Yep. Minus what? Minus what? 6,000. Like that? Is that is that in standard form?
Yes.
Yeah. Are the numbers big?
Yes.
Sure. But again, is it standard form? Yeah. Sure.
You should track the 220
The rate, we want it to be positive, so our R is going to be equal to 980 plus 1220 all over 44. Get 980 plus 1220 divided by 44, and you end up with 50. Is that pretty cool? Is that a realistic answer? Yes. On a test, here's the thing, kids. I would not, if I gave you a question like this on a test, almost certainly you're not going to have your calculator. I would not make you do this without a calculator. Because what's the step here that you really need a calculator for? The square root of 1,488,400.
Yeah.
No. But here's the thing. Could I rework this so the numbers aren't as big? Yeah, like, can you tell me? I have a question for you. Which number here, out of all the numbers on the board right there, which is the number that kind of makes it so that it's much harder to simplify this?
40.
Nope, not the 40.
80 over 60.
Be more specific. There's the 88. The 88 is what kind of breaks it there, because if that number was something like 90, you could turn it into 4, 4, 9, and 6, and it would be much easier. But because it's 88, it's not as easy. Then again, does this chart make sense right here? We did a bunch of these. One question I could ask you, for example, I could ask you, fill in the chart. That could be a question. You know, I could say set this up and then stop there. That would be it. I mean, this requires understanding what you need to set up, right? Or maybe I could say build the equation, but I could say build the equation but don't solve it. That could be a fair question. That tests your knowledge of what I'm asking for right now. Because again, we're looking at attacking quadratics. Are we always going to be starting with a standard form quadratic? No. Okay, so what we need to do now is we're going to transition a little bit to 9.5. Oh, you said S. I get terrible name. So we get what? 0 equals 2t squared plus kt minus what? S. You know what? I'm just going to, I'll keep it as S. It's just going to be annoying. Is this technically in standard form?
Yes.
Sure. And what's the first method you like to use if you can? Does this one look like it's going to be fun to factor? No. So what are we going to need to use?
Either
Yeah, quadratic or completing. Now, generally speaking, unless I say use completing the square or you have a very good reason, and that very good reason could be me telling you to, right? Don't. So let's take a look at this. What does A equal? Yeah, A equals 2. What does B equal? K. And what does C equal? Negative S. Negative S. It's a constant. T is the only variable here. Think of this as any number, but it's going to be negative that number, okay? So does our work change? Does the quadratic formula change depending on what you put into it? No, it's the same method. So what do we find first, Liv? What do we find first? Yeah, b squared minus 4ac. Well, that's going to be k squared minus 4 times what? 2 times negative s. I'm doing the best I can to draw an s instead of like a 5. So what does that simplify to? K squared plus what? K squared plus 8s. Yeah, it's 8 plus because there's 2 negatives. So what do we now have? We know that t is equal to, what's the b value? Negative b. What's the b value? So negative k plus or minus the square. Oh, what's the discriminant?
K squared
Plus all over 2 times a. What's a?
2.
So 2 times 2 is?
4.
You have just used the quadratic equation and you've solved for t. There it is. If you had a value for s, could you plug it in right here?
Yeah.
Sure. If you had a value for k, could you plug it in? Yes, but the idea is this is the solution for any value of k and any value of s. I know you might want to try to simplify this. Careful. Is there anything we can do to simplify this? Be careful. No. Some of you might be tempted to simplify what part of this? Don't. Why not, Mar? Why can't you just simplify the k squared and make it k right there?
Oh, right.
Remember, you got this square root of k squared plus 8s. You might think, oh, it's k squared plus the square root of this. Can you do that? What's 3 squared? 9. What's 4 squared? 16. What's 3 plus 4? 7. You know, 5 is not equal to 7, right? If you square root the sum of those things, it's not the same thing. Just be careful. You're done at this point. All 9.4 is essentially doing is giving you more tools to set up word problems, which aren't impossible, but you need to be very careful. You need to be really, really, really careful. Super careful. So let me find one more of for the first one. What should I do first? Multiply by v squared, yeah. You get v squared w is equal to kfr. Excellent, very good. What now? Yeah, v squared is equal to kfr all over what? Now what? No. Square root both sides. So v is equal to what?
Square root of kfr.
That's half the answer. Plus or minus. At this point, I would give you full credit right here. Absolutely. Except there's one last thing you could do, and I'll get to that in a second. But do you understand what we just did right there? Multiply by v squared divided by w, and then square root it. Everything else is just not v, so we don't care about it. Yes, Mar?
Did you multiply?
First step on this one. Yeah. D squared is equal to 4a over. Now what? Yeah, pi d squared equals 4a. Yeah, so a is equal to pi d squared all over 4. All done. So what do you kind of have to do first on this one? The variable we're solving for, capital R, how many times is it written in that initial equation? It's, well, 2 times. It's,
What if you write out the r plus r squared?
yeah, you will. I'm saying right now, in the initial equation, you have 2 of them, right? You just have to make sure you get them all on the same side. So what do you kind of have to do at this point? What do you want to do first? I don't like fractions, so what am I going to do? Yeah, Harry.
Multiply by r plus r squared.
Yeah, it's the same thing we did before. Good. We're not done yet, though, right? We're not even close to done. Now what?
Divide by p.
Sure, you could divide by p. Good.
And then
Okay, those are all things you can do. The challenge is that how many r's do you have here? Yeah, you have to make sure one of them is going to be squared. One of the r's is going to be squared, and the other one isn't. So what are we dealing with here? What kind of function have we been dealing with for the past week and a half? A quadratic. So what you've just outlined is totally fine, but you have to isolate r, and that's not going to get you very far. What could you do instead? Instead of dividing by, you could divide by p at this point, but what should you multiply out at this point?
The r plus r squared.
Yeah, you're going to need to multiply the r plus r squared out. And what do you get? Little r squared plus rr. Hey, nice, it's Pirate Land. Plus r. Come on, that was funny. Take a look at what I just wrote down and see if you agree with what I just did. What do you think? Does that work? No, it's not always right. I remember I forgot the r before in the last question. R. So what do we have here? R squared plus 2rr plus r squared equals e squared r. Take a look at that. Did I make any mistakes?
No.
Nah. What do I really need to multiply by, though? I have to take that p and I need to multiply it in, right? So what do I end up with? PR squared plus 2r. Now, I like PR before, yeah, PR. Oh, does it matter if I capitalize? Yes. Okay, so this doesn't look like it's nice, but again, which variable are we trying to solve for here? R. What do we have? R, and we also have it right there, right? Is this in standard form? It's almost. Does it equal 0? No, so how can we make it equal 0? ER, right? And I'm going to put this in a different order. PR squared plus 2PRR plus P little r squared minus E squared R equals what? 0. Now, why did I put the P capital R squared first?
Because that's the...
It's kind of like, it's got the big R squared, right? That's like the x squared, right? What about just the r's here? What do we have here? R and R. Are there any big R's in this one right here? Any big R's right there? No. So I'm going to regroup this just a little bit differently for you. We have P. Oh, sorry. This one's a little tough, everybody. So bear with me. What do you have? PR squared plus 2PRR minus E squared R plus P little r squared equals 0. All I've done is rearrange. I didn't do anything there. So this is where you need to pause for. Really ugly on this? Yeah. Yes. So therefore, do I really care if you quote-unquote simplify this one? No. I just want you to plug it in and then stop. This is the one I would like you to set up, though. 2 cars left in intersection at the same time, one heading north and the other one heading west. Sometime later, they were exactly 100 miles apart. The car headed north had gone 20 miles further than the car headed west. How far had each car traveled? This is what I'd like you to do. Draw me a picture of what's going on here. Don't solve anything. I just want you to draw me a picture of what's going on. Anybody know where that came from right there? In a right triangle, what do you know? The base squared plus the height squared is equal to the, what's this side called? The hypotenuse. Hypotenuse, yeah. A hypotenuse. So yes, if this was A, this would be C, but A squared plus B squared is C squared, but in this case, it's B squared plus B plus 20 squared equals 100 squared. So if you want to solve this, is this a quadratic?
Yes.
Is it in standard form?
No.
No. Write it in standard form for me right now. Don't use your calculator. Write that in standard form for me. Write it in standard. No? I get B squared plus B squared.
2B squared plus 40B minus 1000. Minus 600 plus 600 equals 0.
So I get b squared plus what?
2b squared equals 40b
Ah, so 2b squared plus what?
40b plus 40b plus 600.
Plus what?
600.
Where'd you get 600 from?
Minus
9,000.
Oh, Liv steered me.
9,600?
It's okay.
I think that's what it's supposed to be, right? 400 minus 10,000, right? 100 squared is 10,000. I'm going to let you go in 2 minutes, kids. Don't move. So at this point, is this quadratic in standard form? Can someone tell me what I could divide everything by to make it just a tad easier? 2. So you have what? B squared plus 20b minus what? 4,800 equals 0. Yay. Now here's the question you really want to ask yourselves. Oh, sorry. What is distance? You want a positive number. Okay. So kids, be careful on your homework tonight. It's from 9.3 and 9.4. Good luck.